Make sure that you all know that this session will be recorded and we will make it available as soon as we possibly can on our website. So the first two sessions are already up with links, and we'll be adding the third session link as soon as we can. This year, we've partnered with Silicon Valley Math Initiative to give parents a glimpse into what the new math framework will look like when it comes out this spring here in California, as well as what next steps would be on how to collaborate together with you to enhance our current math progression at the secondary level. Tonight, we will examine the changes in policies of the state of California, the new enrollment requirements from University of California campuses, California State University campuses, Stanford University, and others. We have more information about the draft of the new California framework for mathematics that we will share in detail. We will explore the shifts in classroom instruction that are called for in the new math framework, and then view a secondary math lesson based on recent education research. Santa Clara Unified School District's goal is to create a culture in which all students have access to classes that will prepare them for college and career success. In preparing to address the new framework and changes in colleges and universities, mathematics pathways for students admissions, we are hosting virtual family nights through this school year. This is the third installment of 4 sessions that we're doing. Tonight, we are joined by our Assistant Superintendent of Ed Services, Kathy Knable, as well as our secondary math TOSA, Rachel Feinstein. All 3 of us will be answering questions in the Q&A of this webinar. That anything that comes up that you have a question about, we'll be using the Q&A to answer any questions that you might have. We are also joined by Veronica Navarro, who will be supporting us with translation in Spanish tonight. At this point, I would like to introduce David Foster and Tracy Sola from Silicon Valley Math Initiative, who will be taking us on our journey. Thank you.
Thank you, Matt. And it's great to be here with you tonight. I am going to share a PowerPoint screen here. And hopefully you can see it. Tonight, we're, as Matt said, is the third of 4 parent and community nights around mathematics and focused on reviewing the draft of the California Math Framework. I'm going to start with a couple of slides that I've shared before, but I think we need to start sort of at 35,000 feet and get a sort of global view of mathematics here, even in our world and in the United States. This slide that has been shown before is about an international test that is given every 2 years. And it focuses on students' ability to use math in problem solving. So it's not necessarily exactly problems that you would learn in a math course in school, but rather to see whether you could solve real life problems using the mathematics as a student you have learned in school. And you can see the range of performances. If you're in dark green, then you are scoring at the very top of all the students in the world. And as the green moves to out of the green and into sort of a tan to orangish brown color, you have actually dipped to below average. And you can see that the United States itself is the median or below the median or below the average of countries in terms of performance. And these are for 15-year-olds. And that we are scoring significant below other countries that we want to be competitive with, like Western Europe, China, Japan, and Canada. So with this as a sort of a signal that we in math education in the United States need to improve the performance of our students, I want to look more specifically at our country as a whole. And uh, every year, students are assessed at grades 3 and grades 5, 8, and 10 on what we call the NAEP test, or the National Achievement of Educational Progress. And we look at the scores in English language arts and in mathematics. And basically what we've seen for our 8th grade students in this country is that our performance has been flat and actually has decreased slightly from 2000, the high in 2012. Of course, this only goes up to 2017. We know that we haven't received scores from over the pandemic, but up until the pandemic, this has been, our performances have been rather flat, and we need to improve. And also very glaring is looking at actual data. And this is from California in specific, and the state test, the Smarter Balance test that is given each year to students in grades 3 through 11th grade, and looking at this disaggregated data, both in terms of economically advantaged and disadvantaged, and the role that race plays in terms of student performance. And we know that all students can learn, and these are pretty alarming statistics that have shown how economically disadvantaged and students of color do compared to white students and Asian American students. I want to stress the value of calculus, because I'm going to give us some interesting data around calculus. Now, no one is against calculus by any means, and calculus is extremely important for students who want to measure in STEM fields. This comes from an engineering department. And Tracy, will you read it for us?
Sure. Calculus is concerned with two basic operations, differentiation and integration, and is a tool used by engineers to determine such quantities as rates of change and areas. In fact, calculus is the mathematical backbone for dealing with problems where variables change with time or some other reference variable, and a basic understanding of calculus is essential for further study and the development of confidence in solving practical engineering problems.
So I want to put this statement out that it comes from the engineering field, and acknowledge that calculus is important for students who want to go on to STEM field majors. But I also want to acknowledge the role of calculus to the general population of students. I want you to take a moment to examine this chart, and I want to explain it. First of all, this data comes from a past president of the Mathematical Association of America. This is the organization where research mathematicians and professors of mathematics belong. And David Bersu has been studying the role of calculus in high schools and leading up to how kids succeed when they go on to college and continue studying in calculus. Basically, over here on the left, it says high school students, high school calculus, 16% of the students. So what we're saying is 16% of students in our high schools are studying, or in the are studying and will take some form of calculus. Just 16% of the students. Now, of those 16% of the students, that's what we're talking about in this big circle. So of the students who study calculus, 2/3 of those students don't bother to take the AP calculus test. The AP calculus test gives you credit in college for taking high school mathematics or the AP calculus course, AB or BC, either one of those. 2/3 of the students don't take it. 17% do take the test, but they do not pass with a 3 or better. So if you don't pass with a 3 or better, you get no credit for taking that AP calculus in high school for college. The next percent that got is actually smaller than 15. I forgot what it is because my graph isn't working, but it's even a smaller percent of the students who do pass. So these kids actually pass the AP course, but then they decide to just enroll in the same level of calculus they did in high school. So by taking it in high school, they're just repeating the course a second time. And then that means only 3% of all students from this group of 16% actually get to enroll in the second semester. So they actually get the advanced placement that advanced placement means. And what that actually means, of all the students in high school, less than 0.5% actually go on to enroll in calculus. So that's basically one student out of every 200, or out of 200 kids, one student from high school will go on to advanced placement. The other 199 will not. Now, we want every single one of those 1 in 200 to be able to take calculus, take BC calculus, even take multivariable calculus. Nobody is saying no to that. But to have a policy that is only about getting kids into that course doesn't make sense for our world. And that is actually what's been driving the math curriculum at high school for many years. This is Dr. Bill Jacobs. He's from the University of California, Santa Barbara, and he is a former vice chair of the Academic Senate and chair of what's called BORS. BORS is really important. It stands for the Board of Admissions and Relations with Schools, which oversees all the matters of admissions into CSU and UC. So he basically was the chair of the board that decides what the admissions is to get into a UC campus, UC Berkeley, UCLA, UC San Diego, all the UCs, and also all the CSU systems from San Jose State to San Francisco State to CSU, Fresno, and the like. And here is what he says. Will you read this for us, Tracy?
Sure. The districts I have worked with have found that accelerating students into Algebra 1 is a serious mistake because a good many students don't stick with math past 9th or 10th grade because they get burned out or struggled more than anticipated. Then they are not as well prepared for the university as they could have been. And while some students do 2 years of calculus in grade 11 and 12, the risk and damage to the others is too high to justify it, in my opinion. It is very difficult to predict who will be successful 4 years down the road when a child finishes grade 6, as too many changes go on in the intervening years. Personally, with the Common Core State Standards offering a well-designed 8th grade course, I wouldn't push students to accept the very strongest ahead of that course either. We want as many students to take 4 years of math in high school. And if they get accelerated, a good number stop too soon.
He goes on to say, and I'm going to also ask Tracy to read this, please.
Sure. As far as taking AP tests, it is more important that students take an all-around challenging curriculum than race to an extra math AP course. In admission to UC, the readers are aware of AP courses, but not so much the test scores. And so if the student had honors courses that led to an AP course in grade 12, that is going to be about as strong as they can do. If this rush leads to weaker grades overall, the student is much worse off. What I've seen over the past 25 years teaching at UCSB is that the BC calculus really doesn't move students much further forward mathematically, perhaps 1 quarter, 10 weeks at most. And I would much rather see them have a thorough preparation, including applications of geometry in the years prior to calculus. The students who don't have these preliminary experiences have tremendous difficulty in my differential equations and multivariable calculus courses. I know it is hard to persuade parents that their students shouldn't race to get calculus, but I really wish they wouldn't.
Thank you, Tracy.
Mhm.
So one of the things that we're cautioning is not thinking of mathematics as a race, but thinking it as a way to fully prepare for the career and career opportunities that students want in the future. So it doesn't matter who gets there first, we just want them to be well prepared to be there. So racing oftentimes contributes to understanding that is just what we call a mile wide, but only an inch deep. In other words, you've seen lots of stuff, but you can't remember a whole lot or apply it going forward. But the good news is our educational system understands this. And so colleges and universities are changing. One organization, which I'm actually a member, the California Mathematics Education Collaborative, is an intersegmental math leadership group comprised of representatives from the UC system, from the CSU system, from the community college system, also from TK-12, such as Santa Clara Unified School District, and also specific organizations such as the California Math Project, which is funded by the state, the California Department of Education, and other groups. 2 of the working committees that are looking at what's happening is one about how to improve instruction in mathematics around equitable outcomes and social justice for all. So making sure that every single student has the opportunity to learn mathematics in a deep way so that they become college and career ready. The other is one called Math Pathways Options. So maybe instead of all students racing to get to calculus early, we can provide math pathways that would align with what students are going to study when they go to college and universities and what careers they want in terms of maybe computer science, maybe data analysis, statistics for our doctors so that they are well informed. Those kinds of math options we want to be able to make available to all students. And this is tied to what's happening in every state in the nation as they consider a recommendation from the University of Texas at Austin at looking at more and varied pathways for students. So UC and CSU admission policies have changed. I'm going to have Tracy read through what some of those changes are.
Okay. UC has changed its admission policy and does not use the SAT or the ACT standardizing testing. UC and CSU have adopted a new policy for A to G requirements and specifically the Area C math requirement to include UC's Board of Admissions and Relations with Schools unanimously endorsed the policy changes to increase the high school math course options for students as both a college preparation and equity issue. By clarifying the definition of college math readiness and expanding the choices of Area C math courses, students can take to be eligible for UC admissions. Students should be encouraged to pursue the mathematics education most relevant to their academic and career goals. The list includes introduction to data science and statistics.
Thank you, Tracy.
Mhm.
And how about your alma mater, Tracy? What have they said?
Okay, let's see what the farm has to say. Changes to Stanford's admissions recommendations. Stanford University has altered its admissions policy and statement to discourage over-enrollment in AP courses. Mathematics, 4 years of any rigorous mathematics incorporating a solid grounding in fundamental skills, algebra, geometry, trigonometry. We also welcome preparation in skills related to statistics, data science, and calculus. The students who thrive at Stanford are those who are genuinely excited about learning, not necessarily those who take every single AP or IB, honors or accelerated class, just because it has that designation. Overall, we look for thoughtful and highly engaged students who will make a difference at Stanford and in the world beyond.
And also, recently, we have just heard that Harvard is making the SAT optional for admissions at least up and through 2026. So it's not just small colleges, but some of the most prestigious, I would say, colleges are rethinking their admissions requirements and what kinds of courses kids need to take to get into their distinguished institutions. So I want to, after sort of thinking about how the colleges are changing, I want to talk a little bit about the California math framework in the new draft that is being proposed. So frameworks come about every 7 years or so. We're delayed a little bit because of the pandemic. So we're actually doing this in years 7 through, years 8 and maybe 9. But these have been, we've had frameworks in doing these kinds of frameworks every year since 1985. This is the chief writing team, although this writing team is back and was given their sort of their design and walking papers from a large group of 200 educators and experts in mathematics. So it's not just these 5, but even a much very larger committee that recommended actions to these 5 writers. I want to give you an update on the new draft of the California framework because we've already gone through a whole more than a semester of getting input about the last draft. So Tracy, why don't you read to us what's happening with the new draft?
Sure. Tonight, we will be reacting to a past version of a document that no longer exists because the revised draft is with the California Department of Ed and should be out this month after being revised. There will be 2 months of open review period for any and all to respond or comment on this new draft version. The authors make the following statement. The language around tracking acceleration has been rewritten. Those 2 terms do not exist in the new version. Instead, the language describes the need to open up opportunities for all students and not be reserved for special identified groups of students. It does not call for tracking or detracking, but rather structures to make mathematics more equitable for all students.
Thank you, Tracy. So this last quote is from the authors that we just saw. The draft sits with the California Department of Education because it's the CDE's policy to make sure that every word, comma, period of anything that's produced and comes out of the CDE has been looked over to ensure that there aren't no mistakes and that all the language is proper. And anything that is developed by the CDC has to follow those guidelines. So that's what the delay is right now. And we should be seeing a new version out by the end of the month. Just to let you know, the California Math Framework, whatever version it is never a mandate by the California State School Board, but rather a carefully reasoned recommendation addressing past failures and challenging math education in the state to improve. So it's a recommendation document. The other thing is specific around this framework coming out. It does not change the math content of what's being asked of students in any way. The standards are based on the last framework and basically what the Common Core standards in mathematics is. So they'll continue to be replaced. So anybody that says that the math is being dumbed down or changed or revised is incorrect. The math content will be the same. It'll be based on the same standards. What the draft document maintains and doubles down on is what we call the verbs of doing mathematics, or the Common Core state standards in mathematics called the Standards of Mathematical Practice. And I'll share what I'm going to have us do right now is listen to one of the authors of the framework and hear directly from her what is the changes, and asking and answering some of the critics of the first draft and answering the concerns that are heard.
Good to have you on.
Thank you for having me on, Kristen. I'm looking forward to clearing up all of these misconceptions.
All right, well, we have about 8 minutes, so tell me what's wrong with the way math is currently being taught?
What's wrong is most people will tell you that people are very bored in maths classrooms, and it's taught as a set of procedures, and people are not really engaged. They're not working on complicated, enriching problems. So one of our biggest messages is let's change that. Let's teach really engaging content in meaningful ways for students and have them work on really exciting maths problems.
Okay, so far you probably won't encounter a lot of arguments with that, but the plan lists as one of its goals the dismantling of systemic racism in math. So critics have jumped on that, saying it injects race into math. What do you say to that?
What I say to that is mathematics is the most inequitable subject of all school subjects. If you look at who goes forward in mathematics, you can predict that by their gender, by their racial background, and we shouldn't have that situation. And we've had that for a long time in mathematics. It's part of the way the school system is set up. And we want to change that. We want mathematics to be a subject that everybody enjoys and is given access to.
Okay, so part of what you propose changing up is this tracking mentality, right, beginning in middle school. But people who have caught bits and pieces have heard this plan means no accelerated math in middle school, no algebra until 9th, everyone sticks together through 10th, and no calculus in 12th. I mean, are those things true?
No, not really. So what we're trying to highlight is that the current system, which is tracked, is very inequitable and not very effective. So the system that we have at the moment is, in many districts, in 6th grade, about half the students will go on one pathway and half the other. And those who don't go on the higher pathway will never get the chance of going to calculus in high school. Their options will be closed off at that point from going into STEM, for many things. And we don't know what 6th graders can do. So what we're saying is we need to change the system. And yes, we know that students are at different levels, and we're not trying to say, well, we're definitely not saying everybody should learn the same content at the same pace. What we are saying is that there are more flexible ways of having kids go at different paces.
Yep.
And we really, want to recommend those to people.
In fact, we have a graphic of some of those flexible ways and different paths that we can show people as you walk us through it. So this is for high school. Walk us through what you're proposing here.
So this is showing one way that students may be going through high school. Everybody has to take the content of algebra and geometry. One of the big messages of our framework is actually, let's not teach that as separate courses. Let's teach it as integrated mathematics, as the rest of the world does. After those years of taking what is algebra and geometry, what we're saying is there are many, many options now for students. So another big message of our framework is students in California can actually take data science instead of taking algebra 2 if they want to. The whole UC system communicated that for high schools across California. So we're trying to put out a much more flexible options in high school, that maybe you take data science and calculus, or maybe you want to go on that algebraic calculus pathway. But for many students, data science is a much more engaging option where they're actually analyzing data from their world and they're asking really important questions that help their community. So we're very excited about this new data science pathway.
I think that makes a lot of sense, and statistics certainly very useful. Like, look, I took calculus in 12th grade knowing that I would never pursue an engineering path. And quite frankly, I didn't understand it, but I knew colleges were looking for that. So unless you had the buy-in of colleges, this is not going to work, right?
Right.
So,
but we do have the buy-in of colleges, and that's what's really exciting, particularly in California, which is kind of leading the way in this. So as I mentioned, the whole UC and CSU system is communicated. We value students who take statistics and data science. You don't need to go on that calculus pathway. We will value you equally when they look at applications. Mm-hmm. So it's actually a myth that they're looking for kids to what we call race towards calculus. So we know that the majority of kids who take calculus in high school actually retake it in college. So there's something wrong with that we have this sort of race towards calculus, students go very fast, they don't get deep understanding, and then they have to retake it when they go to college. So the framework is trying to address that.
Okay, but if you don't have accelerated classes in middle school, for example, right? How do you account for the differentiated learning that, may be required because kids are at different places in math? Is that not assuming that all the teachers will be super capable and super able to kind of read everybody and give them all exactly what they need? But given,
yeah, that's a great question.
That's hard.
Yeah, that's hard. And so there's two different ways of having students be able to be met where they are, if you like. One is that teachers are using much more open, complex problems. Students can take them to different levels. High achievers can take them to very high levels. That is hard. It's a fantastic way to teach. Many teachers teach in that way. And another way is something that's very popular in Silicon Valley and other places, is that students are actually on their own pathway. They take assessments that tell you where they are, and then they get content that's helpful for them. And when they finish that content, they take some sort of assessment and can move on to the next content. So it doesn't have to be so lockstep. The district will decide that you are in different classes and you will all move at the same pace through mathematics. We don't agree with that. We think that there should be a lot of flexibility so that different kids are doing different work that is really just at the right place for them.
All right. I mean, I think the execution of that probably requires a whole lot of investment and work to get there. But let's talk about how this can meet the needs of not just the kids who are, needing a little more time in math, because I get that idea where if you're told early on that you're just getting the message that you're no good in this, you kind of give up. So I get how this counteracts against that. But does this work just as well in ensuring that the kids who are more into math earlier on also are served to their full potential and not just okay, but actually thrive?
Yeah, it certainly does. And we've based these recommendations not just on, people saying this was good for my student, but years of research. And what that shows is when you give students these different approaches I've described, the high achievers actually accelerate more than any other students. They have a fantastic time being able to do these rich problems. And so tracking and having kids go through at the same pace, turns out it's not good for the low achievers. We can probably all understand why, but it's also not good for the high achievers. They're often locked into this particular content. So we want to make it more flexible, more open for all students. And we know from research that it does help all students, including the high achievers.
Mm-hmm. All right, well, Professor Joe Bowler, Stanford education and designer, one of the designers of the new math curriculum. I know that you're still in the phase where there's still more public hearings and people will get a few months to weigh in, and you're looking at, right, making a decision in November.
And we're really listening to the comments that have come in, and we will be making adjustments. So
thank you.
I hope everybody will like it.
All right, we'll keep the conversation going. Appreciate your time.
All right.
Good to have you on.
So I want to just talk a little bit more about this diagram that was presented in that talk with Dr. Joe Bowler from Stanford. And it's this idea that students get a firm basis when they enter high school in terms of whether it's a traditional pathway of Algebra 1 and geometry, or an integrated path room where each year you have some algebra and some geometry, like the way that the rest of the world teaches, or even what they call an integrated content that really stresses deep understanding and beliefs. But as they move through high school, then they have options. They have options of doing the traditional Algebra 2, trig, pre-calculus, calculus, and making sure that there's a pathway that any student who wants to get through calculus in high school can, and pathways to allow students to do that, as well as continuing in an integrated program or focusing on mathematics that you might need more in your major when you go on to college. Things like what we talk about as data science. Actually, here in the Valley, in Silicon Valley, data science jobs are more prevalent than any other jobs in technology. Statistics for those who want to pursue really looking at data and research, and this idea of modeling with functions, looking at ways to attack mathematics and solve real world problems. Also under the other there are things like AP Computer Science or AP Physics, AP Chemistry, and others. So we want to have options so that all students can meet their needs and be able to achieve and be ready for the college and career that they want to engage in. The new framework has basically 4 areas in which we want to look at and preserve. One is on chapter 2, which is talking about really engaging all students in mathematics and getting them to believe that they're good at mathematics, great problem solvers, and to learn mathematics in deep ways. The second is chapter 4, and chapter 4 is about exploring, discovering, and reasoning with and about mathematics. The SMPs, which I'll share in just a minute, are the verbs of doing math. So this is doubling down on getting kids to not just do mathematics, but understand why and be reasoning through. The fourth big idea that spans the chapters for K-5 math, 6-8 math, and high school is this idea of teaching to the big ideas. So really focusing on what is the most important big ideas in mathematics and looking at that. And finally, chapter 9 is equitable pathways. So that diagram that we just talked about before, they go into depth explaining what those pathways are. These are the standards of mathematical practice that a number of slides before have referred to. These 8 standards are actually measuring the doing of mathematics, not just what you learn, but being able to solve problems and persevere in problem solving, being able to reason, being able to make viable arguments and critique others' reasoning. Modeling with mathematics is the act of actually taking a real world problem and then creating a mathematical representation or structure that you can use to solve or manage a problem in real life. We also talk about the tools of mathematics, which definitely include the use of technology and how technology is used in real life to solve a lot of problems that you could only do by hand just a few years ago. And finally, the last 3 are really about looking at the structure of mathematics and using it to make sense of the world. So the framework is really looking at how teachers can teach these and teach these in more effective ways. You can see the chapters of the proposed framework. Some of these might be altered in the next version, but basically this is what the table of contents looked at in the first draft that we just reviewed. Tracy, will you go and read us about teaching to the big ideas?
Sure. Rather than organizing teaching at the individual standards level, teaching to big ideas reveals important concepts and the ways concepts are connected more fully. Approaching instruction through big ideas and connections allows time for students to more deeply explore fundamental ideas, which can link multiple practice and content standards. The same content is actually taught and learned, but the organization into big ideas allows for a more coherent approach. And this is adapted from a book called What is Mathematical Beauty?
So what they're saying, and we'll go just down to the kindergarten here, on the left is how a lot of curriculum in the past has been looked at. They've listed actual standards from the Common Core standards and says, you need to teach this. But this is lists, and lists lots of times don't make sense as a whole. They make sense individually, but how does one standard relate to another standard? And how does that make sense to a student who is trying to learn and understand an idea? Instead, on the right is what we see is a network map about what are the big ideas at kindergarten, how are they related to each other, how do they connect? So we're talking about what are the big ideas and how they connect with one another. This is going to help teachers teach students in a more coherent and understandable method. So the chapters that I listed that were really important are, first of all, chapter 2. So Tracy, will you read to us what chapter 2 is focusing on?
Sure. Plan teaching around big ideas, use open, engaging tasks, teach towards social justice, invite student questions and conjectures, center reasoning and justification.
Thank you.
Mm-hmm.
And then chapter 4 was this idea about increasing the reasoning and getting students to understand math in deeper ways. So Tracy, will you please read what there's the summary of what this chapter is about?
Yes. Reasoning is at the heart of doing and learning mathematics. Math classroom discourse must become a vehicle to reason. Student conversations with themselves, each other, their teacher, and the whole class are the soil upon which reasoning grows. This will spark and follow students' mathematical curiosities. What does it mean to do mathematics? How often do we offer students opportunities to conjecture? Students take on the role of the skeptic and ask questions to make statements such as, how do you know? And prove it. This is all included under Standard for Mathematical Practice 3, construct viable arguments and critique the reasoning of others. Standard Mathematical Practice 7, look for and make use of structure. And SMP 8, looking for and express regularity in repeated reasoning.
Thank you, Tracy.
Mhm.
And then the next idea that Dr. Bowler talked about and that she has collaborated with a lot is Stephen Levitt from Freakonomics. And so they devoted an entire chapter to this very important area of data science, which I said is the area which more jobs are available to people in Silicon Valley than any other jobs, or any other category of jobs. So Tracy, will you read to us what this says about data science?
Yes. The ability to work with and understand data has become an essential life skill in our newly data-filled world. 90% of the world's data has been created in the last 2 years, and 7 of the 10 fastest growing jobs in the United States involve working with data. This data-rich world requires a capacity to understand and draw meaning from data. It is not only those who have careers in data science. Almost all occupations now require that employees collect feedback from data and adjust their practice. Everywhere we turn, stories about the world are illuminated by massive quantities of data, and community members need to be able to make sense of data to separate fact from fiction with respect to their health, finances, and news feeds.
Thank you.
Mhm.
So this timeline is being adjusted, but the goal here is to, it's going to be a little bit later, but starting at the end of March and going for at least 2 months, there's going to be a 60-day public review of the newest draft that isn't quite out yet. And then after that, the goal is for that data to be reviewed and advised over the summer, and a final draft out, and sometime probably in the late summer, probably August now, the state Board of Education will take action on either adopting or relooking at the framework. So that's the timeline that we're looking at for this new framework. So SVMI is partnering with your district, the Santa Clara Unified School District, to help the teachers understand these changes and to support what we call mathematically powerful classrooms, where teachers will be able to have the support to make changes to teaching to the big ideas and looking at options and pathways to improve teaching and instruction. So I am going to stop this for a minute. Sorry, I meant to, yes. And I am going to move ahead to make, sorry. Let's see if I can end this by sharing one more slide, excuse me. And I'll share it. And so I'm going to conclude now and throw it back to Matt for some final comments. But our next and final math parent community meeting will be on May 3rd, and it'll be once again from 6:30 to 7:30. And we're going to be focusing on this idea of looking at actual classrooms and how we can make math learning more engaging for our students, and to ensure that more and all of our students hopefully are mathematically powerful. So with that, I will stop the deck, turn it over to Matt, and thank you all for coming out tonight.
All right. Thank you, David. Thank you, Tracy. Thank you, Rachel and Kathy and Veronica, for all of your work and behind the scenes. She doesn't get enough credit, but Secondary Ed Secretary Michelle Schmitz, who was hosting our webinar tonight. So thank you. Just want to say thank you to everyone who's come in our community to be a part of this. Like I said, there's the third of four installments, and David just kind of outlined what we're going to be talking about next month. Simultaneously, we have teachers that are part of a cohort that are doing similar work and looking at the new framework, or what is expected out of the new framework, and starting to prepare some innovative, different pedagogical techniques that they're trying in the classroom. And so, but there's a lot more to come. We're just kind of starting this process. We're looking to engage with all of the members of our community on what this could look like in Santa Clara, and make sure that we're doing what we know is best for our community. And there's lots of different possibilities and options, and we look forward to the collaboration. Kathy, is there anything you want to say, or?
Just thank you very much for being here, and we hope that you will join us in these conversations as we move forward. We want the entire community to be engaged in these changes in order to offer all of our students the opportunity to succeed in math. And I know we didn't get to all of your questions, and we will review those and hopefully be able to answer them in our next presentation.
All right, everyone, have a great night. Thank you.